Hello everyone, my name is Abhishek and welcome back to my channel. Today is episode 23 of Azure Zero to Hero series, and in this video we will learn managing Azure resources using Terraform. We will start with learning how to connect Terraform with Azure. Then we will learn how to manage and create resources on the Azure platform. I will take a sample infrastructure configuration. I will show you how to write the Terraform files, which is the HCL files, what plugins and configuration is needed on your Visual Studio Code. Then I'll show you how to migrate the state file onto the Azure blob. We will learn about the state file management and the state file migration. Finally, I will also share some best practices that will help you during your interview. So this is going to be what we are going to do in this video. Just to mention one thing, if you haven't followed or watched my Terraform playlist in the past, I have a Terraform Zero to Hero playlist on the same channel where I have explained Terraform right from the basics. There are 10 videos in the series, which comes to 5 hours. And using this playlist, you can easily clear the Terraform Essential certification. And this will definitely help you learn Terraform with AWS. But this video, we will focus Terraform with Azure. So let's get started. Let's start with understanding what are we going to implement in this video. So I will be creating a virtual machine. So to create the virtual machine, first we need to create a virtual network. So we will learn how to create a VNet. We will learn how to create a subnet. Then we will see how to create an NIC. Finally, we will create the virtual machine and attach all this configuration to the virtual machine. And then for someone to log into the virtual machine, we will also be creating a public IP. We will attach the public IP to the virtual machine and we will assign a SSH key value pair to this virtual machine. And all of these things we are going to perform using Terraform. Not just that, once we complete all these things and once we create this infrastructure on the Azure platform, we will also be migrating the state file that is created onto the Azure blob storage. So we will create a blob, a container on the Azure storage account. And within that storage account, we will move the state file to the blob. So you will learn about the state file migration as well. So it's going to be very interesting. Please try to watch it till the end. First things first, like even before I explain how to use your Visual Studio Code, how to start writing the files for this, let me explain a very simple question. Why Terraform for this? Right? So why should I use Terraform? Abhishek, one is I can create all of these things using the user interface. Other thing is that I have other automations which you have explained in the series, right? In this series, I have explained about the Azure Resource Manager templates. Excuse me. I have explained about the Azure CLI. And I was also talking about the Azure SDK. And we were also talking about the Bicep. So there are so many automation tools out there which Azure supports natively. Then why should I go with Terraform? Or why cannot just I use the user interface and click few buttons and create those resources on the Azure platform? So one, straightforward, this is a no, because you should be only using the user interface to learn things on the Azure platform. As a DevOps engineer, this is not at all an option for you. It will just waste your time. So a strict no to the user interface. Now, how about all of these things which are pretty cool, right? So if you look at Bicep, which is a pretty advanced Azure resource which can automate things on Azure. Then you can, if you are good with programming, you can also use the SDK, or you can use the CLI and templates. A very straightforward answer to this is, as a DevOps engineer, let's say you are working in an organization where the organization is using AWS, Azure, and GCP. Let's take an example. So they are using AWS for the AI and ML services. Let's say they are using TensorFlow and they're using it on the Azure platform, and they are using CI/CD with Azure DevOps. And let's assume they are using the Kubernetes platform from the GCP, right? Let's say they're using the GKE. So now, as a DevOps engineer, let's say you join this company. Of course, these cloud providers, they provide their own automation tools, such as AWS provides CFT, Azure, let's say, provides Bicep, and GCP, let's say, provides an SDK to automate things. As a DevOps engineer, it is not that easy that you get command over CFT, Bicep, and SDK. In future, if your organization moves to OpenStack, then you should also be learning the Heat templates. If your organization moves to the DigitalOcean, you should also learn their APIs. So it is very easy if you have a unified platform that works for all the cloud providers and any new cloud provider that is introduced and becomes popular. So Terraform is that one option where Terraform provides something called as HCL, HashiCorp language. And as a DevOps engineer, you can use this HCL or the HashiCorp language, also called as Terraform scripts. Using this Terraform files or scripts, you can just talk to the Terraform, and Terraform will talk to any cloud provider that it supports. Most of the popular cloud providers Terraform support. So if you're looking for AWS or Azure or GCP, Terraform has a very good support, and you don't need to learn the APIs or you don't need to learn the specific automation tools of these cloud providers. Let's try to understand the architecture. Let's just spend a couple of more minutes before we get started. If you take Azure as an example, so what Terraform does is DevOps engineer will write the HCL files or the Terraform files, which are taken by the Terraform platform. Terraform talks to the Azure Resource Manager. In the previous classes, I have explained the importance of Azure Resource Manager. Whether you are using the Azure CLI, you are using the Bicep or any automation platform, Azure Resource Manager is the one that receives your request, and then it talks to the Azure platform to create the resources. So here, what is Terraform doing that it can talk to any cloud provider? That Abhishek, you said it can also talk to AWS, right? Tomorrow, if I just modify my HCL files, can it talk to AWS? Absolutely. If I modify my HCL files, then can it talk to GCP? Absolutely, it can talk. How? So what Terraform does is it will receive the HCL files that you have written. It converts the HCL files into the APIs of your target cloud provider, and it makes the API request with your target cloud provider, right? So Terraform converts the HCL files or the Terraform files that you have written to the API, and this API will create the resources that you are looking for. So it does all the heavy lifting for you. You don't need to learn the APIs of all the cloud providers. You don't need to know how to make an API request, right? So you can also talk to these cloud providers without Terraform, without using any of their automation tools. But you need to have programming knowledge. You need to have good understanding of how to make the HTTP requests or HTTPS requests using the APIs to these cloud providers. all that thing is abstracted by Terraform, and Terraform converts the HCL code that you have written into the API. That's why it is also known as API as code platform, because it converts your requests into the APIs and it makes the API request on your behalf. That's why it's called as API as code 2. And this concept, as a DevOps engineer, which you are trying to write the HCL files, or it can also be the CloudFormation templates, Azure Resource Manager templates, anything that you are writing, this concept is called as infrastructure as code, because you are literally writing the infrastructure in a templating language. It can be the HCL files of Terraform. It can be the CloudFormation templates of AWS, the Bicep of Azure, or Azure Resource Manager templates, anything. You are literally writing the infrastructure in the templates. So it's called as infrastructure as code, right? You understood the point? And this is why Terraform is very popular, because one, it supports multiple cloud providers. You just need to know the HCL. Two, it abstracts and it does the heavy lifting for you. You don't need to make any API requests. You don't have a steep learning curve, right? Going ahead, if there are any new cloud platforms, you know Terraform will take care of talking to them. All that you need to do is just know how to write the HCL files. Perfect. So we learned what are we going to implement today. We learned what is Terraform, why Terraform, and the advantages of Terraform. If you want to know even more, you know where to go. Just go to the Terraform Zero to Hero. This is just created 6 months ago, and you can see the number of people watch this playlist and how many people like this playlist. So there is so much of information. There are projects. It is the best place that you can learn Terraform. Now let's go to the Visual Studio Code. If any of you don't have the Visual Studio Code, it is very simple to install. Just search for VS Code. Right? It will hardly take a couple of minutes to install. Just search for Visual Studio Code and download Mac Universal or any particular platform that you want. I'm on Mac, so I will be downloading this. If you're on Windows, download this. If you're on Linux, download any of these options. If you want to go with RPM or .deb file, right? So this is how you download. And if you are not on Mac, Windows or Linux, and if you're looking at any other OS architecture, you can also go to the other downloads and you can find it. Perfect. So I believe and I hope you have the Visual Studio Code. Now let me open my Visual Studio Code. You can also parallelly do it with me. And if you have followed my previous classes, you must have seen me using the Azure CLI a lot, right? So I already have the Azure CLI installed on my machine. We are going to use Azure CLI in this video. So if you just type AZ version, you should get this response. Then Azure CLI is installed on your machine. Let's say for some reason you don't have the Azure CLI installed. Again, it's very straightforward. Just search for Azure CLI. Go to the first link that you see. If you are confused, please pause the video and see what I'm trying to do. Click on install, update or run. Click on the install Azure CLI. Then you will get the same options. Install on Windows, Mac or Linux. Let me say Linux. Okay. Then depending upon the distribution, just click on one of these. Let's say you're on Ubuntu. And if you scroll down, you get the commands to install AZ on your Ubuntu machine. Similarly, if you're on Windows, you can just click on this button and you can get it. Why you need AZ? Because as I told you, Terraform talks to the Azure platform, right? Here I have explained you that Terraform talks to Azure Resource Manager and Azure Resource Manager creates the resources for you. But there has to be an authentication for Terraform, right? If you create resources through the user interface, you log into the UI using your username, password, or using your GitHub account. That is how you are authenticating and authorizing yourself. Even Terraform has to authenticate and authorize. That's why we will install AZ on our machine, and then we will run the command called AZ login, right? When you run the AZ login, you can do it along with me. Then it opens a terminal for you. And in the terminal, it will prompt you for GitHub authentication or any sign in option. And once you sign in, you will see this page which says that your Azure authentication is successful. Now, it depends on your user access. If you have access to certain resources, you will be able to create those resources. If you are the root user, you can create any resources. If you are a user, AD user with certain permissions, you will only be able to create those resources, right? You cannot change that. Just because you are doing it with Terraform, that doesn't mean you can create any resources on the platform. Terraform is just a interface for you. Whatever permissions you give it, it can create only those resources. So I did AZ login with the root user. So technically I can create any resource on the Azure platform. Now, okay, I have already done it. If I go to the Day-23 folder, I have the files and I can simply execute them, but I will not be doing it because I want to do it along with you. So what I will be doing is I will create a folder called dummy, right? So this repository is the same one that you are seeing here, right? You can also clone this repository and you can start using it. You can also use the Day-23 folder and files directly, but I want to show it from the scratch. So sorry, it closed. Let me open it one more time. Yeah, so I want to do it from the scratch. That's why I created a file called dummy, and see how easily I will write the Terraform files. So first, let's create a file called main.tf, and we will write the required configuration in the main.tf. So what is my ultimate goal? What should I create? I should create a virtual machine. And Abhishek, how do I know how to write the virtual machine related code in this TF file? Very simple. What you will do is just search for Terraform Azure provider, right? Terraform has providers for the cloud, each cloud platform, and other providers that it support like Kubernetes and all the other things. Because we are interested in Terraform Azure provider, just search for that. Terraform Azure provider is called as Azure RM, which is Azure Resource Manager provider. Why? Because here Terraform is not directly talking to Azure, it is talking to the Azure Resource Manager. And Azure Resource Manager will create the resources for us. This is very unique to Azure, where anything that you create happens through the Azure Resource Manager only. Okay, now Abhishek, I got into the documentation. What should I do? Right? We have already done the first part, authenticating to Azure using the Azure CLI, which explains the same steps that I've done. Now just go here and search for virtual machine. Any resource that you want to create or any data source. What is the difference between resource and data source? You can watch that in the Terraform playlist. I have explained all such things. But for now, any resource that you want to create, just come here and search in the search bar. You will find this Azure RM underscore virtual machine, right? Here you have the complete code for it, right? You can just copy this one. So this is the one where it explains. Okay, let me copy this and explain that in the Visual Studio Code, which becomes very easy, right? So here let's try to understand step by step what it is trying to do. So first, it is creating a resource group, exactly what I have explained. First, to create anything on the Azure platform, you need a resource group, right? So that's why it is creating a resource group for us. Then we wanted to create a virtual network. Of course, the virtual network is being created. Then we want a subnet. So subnet is getting created. Then we want a network interface. The network interface is getting created. Finally, we want the virtual machine. And this virtual machine should have everything attached to it. Like this virtual machine should have the virtual network along with all the resources attached. So that is what is happening here. See, the resource group, the network interface, and network interface has all the configuration related to the subnet and virtual network. See, this is the network interface and it has the configuration of the subnet. So this is how you need to write the Terraform files. And again, if you wonder, but Abhishek, see, I've taken the help of the documentation to copy paste this entire thing. But what if I need a resource that I am not aware of? Any resource that you're looking for will technically be available in this particular documentation. But I have also explained how to learn writing these things. It comes with practice. For example, okay, let's say I don't have this entire thing. And for some reason, I don't even want to look into the documentation. So I have some techniques for you. Number one is go to the extension section. And in the extension section, just search for Azure Terraform. So there are some plugins which can make your work very, very easy. First thing is install this plugin. Please watch that this plugin is official plugin from Microsoft. You might find some similar plugins and they might not be the ones that you have to install. So Azure Terraform, this plugin is a Visual Studio Code extension for developing the Terraform on Azure. Click on the install button. I have already installed. Number two is just search for Terraform. Right? And install the HashiCorp Terraform. Again, this is verified by HashiCorp. Only install this. You can also look at the number of downloads so that you understand you are installing the right one. So two plugins. Number one is HashiCorp Terraform. Second one is Azure Terraform. Now, once you install both of this, your work and your life becomes so simple. Let's say I want to install the virtual machine, as I've explained, or I want to start with virtual network. All that you need to do is just start writing, just say resource. See, it populated the things for me. And now I just have to search for Azure RM underscore virtual underscore network. Right? So it created the skeleton for me where resource Azure RM virtual network, and you can give a name for this resource. Understand carefully, I'm not giving the, it is not name for the resource, but in your next blocks, if you actually want to call this virtual network, let's say you have 2 or 3 virtual networks, right? And you want to call this particular virtual network, you need to give a name for this particular block. So here I can just say example. And then I can simply come here and provide the name for the virtual network, right? And all the parameters that are required for the virtual network. Now the question is, Abhishek, how will I understand what are the required parameters inside the virtual network? For that, whether I am writing the code, whether you are writing the code, everyone has to reference the documentation, right? There is no option in it. You just need to go here, search for virtual network, because we keep working on a lot of things. It is practically impossible to remember all the things that should go into the block. Use the documentation. There is absolutely no issue. Even if you are giving your interview, what is expected from you? The expectation is you write this skeleton and you roughly provide the field names. You don't have to provide the field names exactly. So if I just search for virtual network here, so I got this. I'll just go here, and there are 2 things that I have to mention, right? In the virtual network, I have to mention these fields. Again, out of these things, some will be mandatory, some will not be mandatory. You can understand that by looking at the required section in the documentation. If I don't provide the name, if I don't provide the resource group name, if I don't provide the address space and the location, then you might provide all the other fields. Still, you will see this red sign, which indicates you did not provide the required fields. See here, it is clearly mentioning required address space, required resource group name, required location. And even here it says name, resource group name, address space, and location are required. If I don't mention the name, and if I just copy this entire thing, just for your reference, let's say I copy this entire thing, and if I just remove the name, immediately you will see all the red lines, which indicates your Terraform configuration is incorrect. From where are we getting these? Because I have installed the plugins that explains how to write. This is basically for the auto correction, basically for auto typing your Terraform TF files. Great. If I just enter the name, you are done. Right? Also try to keep the indentation right. So if you don't have the indentation right, it will be difficult to read the configuration files. Perfect. So this is how you have to write. And for the virtual machine, let's go back. So if I just show you how to write it right from the basics, right? I'll just go to the documentation here and I will just search for virtual machine. So let's do it step by step. So here I'll just copy this. Perfect. Paste it. And let's try to just look through it if we have everything in place or not. First, there is a prefix which is called TFVMex. You can provide any prefix. Basically, this is for variabilizing your resources. Like if I can simply provide something like Abhi resources. Instead of that, we are just using a variable, and this variable will help you to variabilize the name. Tomorrow, if you want to just use this Terraform scripts for some other project, right? You can just change this to foo project, right? Or you can just change it to bar project, or you can change it to any other project, right? So here in the example, Terraform has just provided a dummy variable name, and that gets appended or prefixed to the resources that you are creating. Okay, so first we are creating the resource manager, and in the resource manager, we are creating a resource group, and the resource group is getting created in the West Europe region. Let me change it to East US. Okay, I would prefer the resources to be created in the East US because I have a VPN and it is easy to create resources in that region. And then resource virtual network, as we have discussed, next is virtual network, and a name is provided to the virtual network. Address space, you can change the address space, there is no problem. You can change it to the CIDR block range to 24. You can just keep it to 27, whatever you would like to, but 16 is provided as an example. Then this is exactly what I was talking about. If you see here or watch carefully, the location of the virtual network is taken from the Azure Resource Manager group, Azure group name. So how do you take that? Basically, if I have to write this, let's say you don't know how to write it. It's very simple. I have the location defined here. The resource RM group is East US. So what I can simply say, Azure RM underscore resource group dot example. So this is the resource group, this is the example, and then you can simply say dot location, right? So it picks up the location from this particular field. Similarly, the resource group name, you might think that, okay, Abhishek, why do I have to do it this way? I can simply hard code it, right? But if you look at the number of times the resource group name is called, In Azure, any resource that you want to create, resource group name is the mandatory thing. So that's why instead of hard coding it to the East US, we are reading it from the resource that we have created. Uh, just give me a second. So we are reading it from the resource that is available. Perfect. Then Azure RM subnet. And even for the subnet, it is the same thing. You can just go to the documentation, but we have copied the entire code block for the virtual machine. So we have everything in place. So for the subnet, again, we are reading the resource group name. This time we are reading the virtual network name from here and address for the subnet. So this is the CIDR block for the complete virtual network. And this is the CIDR just for your subnet. So it's a part of your virtual network where you are just taking a subnet of range /24. Then in the Azure network interface, we provide the subnet ID, right? So we have created a virtual network, then we have created a subnet, then we have created a network interface, and we will attach that network interface to the virtual machine. See how simple it is. You don't even have to write this entire code, and you got it from the Terraform documentation. You, even if you want to modularize it, you can modularize it. You don't have to change the Terraform block or the code. You just have to write a wrapper on top of it. And let's see what is the configuration of the virtual machine very quickly. So we have the name of the virtual machine here, location, resource group, virtual machine size. What is the storage image reference? What image are we using? What is the OS disk? What is the OS profile? Right? Here we have test admin username and the admin password. And along with that, we also have the OS profile. Now, if you try to create this, okay, let's see what happens. This will fail because, okay, Abhishek, I have copied everything, but why will it fail? It will fail because if you just do Terraform init, where did we mention to Terraform that I want to connect to the Azure, right? Okay, you wrote this entire thing, but how does Terraform know that it has to create the resources on the Azure platform? You don't have it mentioned anywhere, right? Terraform initialized in an, oh, okay, let me, did we go to the dummy folder? Never mind. Is it in the main.tf itself? Perfect. Now, if I try to execute this, now this will run, but where did I provide the Terraform configuration? That is, where did I mention that which version of the Azure RM provider that I have to use? Where did I mention this Terraform that Azure is my provider? Which version of Azure should it use? We haven't provided that configuration, right? So for that, what we need to do is whenever you start writing your Terraform script, you have to provide that provider. What is your provider? Is your provider Azure RM? Is your provider AWS? Is your provider XYZ, right? So you can also technically search for your provider configuration and how do you write the provider information. If you just say this one here, authenticate with Azure CLI, right? You can get the Terraform provider configuration from here. I just search provider here and I can simply copy paste this one. So Abhishek, is it that easy to write Terraform? I'm just copy pasting it from the documentation. Yes, literally it is very easy if you keep practicing. Right here, I am creating an example and I'm creating the infrastructure. But within the organization, sometimes it can become very complicated when you keep writing a lot of Terraform files, right? Infrastructure as a code, if you learn it, if you keep practicing it, only then it becomes easy. Perfect. So now I have provided what is the provider version and what is the provider that Terraform has to use to execute this script. And I've also executed AZ login. So Terraform has all the information now. It has the permissions, then it has the provider information, the version of the provider, and it is all set to execute. But one thing is, the example that we have here is using the username password. But in the Day-23 folder, what I have done is I am using this main.tf, which is exactly same, but only difference is that I am using the SSH public key configuration, which will be better for us because most of the times we won't be using the username and password. So that's why I replace this configuration with the admin. So nothing else is changed. I have just used this particular admin SSH key, and rest all things are same. We will be using the Ubuntu image. Let me just remove the public IP for now because I will explain you how to create the public IP as well. For now, rest all things are same. I haven't used the prefix. So let's try to execute and see. So I'll just say paste Terraform init, right? And what is the name of my resource group here? So the resource group that I am creating is example resources 1. You can add a prefix, you can add variable, whatever you would like to. But for now, if I just see ls, you will see the main.tf file. There is no state file yet because state file is only created once you apply the configuration. Before that, there is one option in Terraform called Terraform plan. Just if you are someone who is beginner in Terraform, it said that at line number 43, you are assigning public IP address. If you go to line number 43, here we are assigning the public IP address to the Azure network interface, but I have just deleted the public IP block, right? Because I want to show you how to create the public IP. That's why I have deleted that block. So what I'll do is I will just run one more time Terraform plan because I removed that configuration. Let's see if it works now. It should work now. And the plan is like a dry run. Before you apply the configuration on your Azure platform, if you just want to check what are the resources that are getting created, if you want to be sure, then you need to use the plan. Okay, it is taking more time. Let me cancel it. Let me reinitialize the Terraform. Okay, let me try the plan one more time. Okay, looks like it started performing the action. Okay, so it clearly explained 5 resources to add, 0 to change, and 0 to destroy. Let's see what are those 5 resources. So this is the best way if you want to verify your configuration. If you don't want to create the resources yet on the Azure platform, you can just execute the Terraform plan and see what resources are getting created. So it is explaining you that, okay, now if you run Terraform apply, I will be creating a virtual network. I will create a subnet. I will create a resource group. I will create a network interface, and I will create a virtual machine. And if you want to see what type of virtual machine, everything is available here. So this is just a dry run. If you are comfortable with the dry run, you can come here and run Terraform apply. And Terraform apply again will prompt you asking, are you sure? Do you really want to create this configuration on the platform? So you can just enter yes, and then it will create the infrastructure on the Azure platform. Enter a value, say yes, and now it will start creating the resources for us, right? So it's very straightforward. Most of the times, the Terraform configuration that you are looking for will be available directly in the documentation. Let's say you want to combine multiple resources in one Terraform script, or you want to write the Terraform modules, then you have to do that effort where you have to, let's say you want to create a virtual machine with the blob storage. So for virtual machine, You have to search for the configuration. Then come here and search for blob. You will get the information for Azure Storage Blob, this one here. So you have to combine both of this information, put it in one Terraform file or module, whatever you want to create, and then you have to change those fields. If you want to learn, let's say, Abhishek, okay, I see that you have hard-coded a lot of information here. It's very straightforward. Just go to the Terraform Zero to Hero and go to episode 2, where I've explained how to write variables, how to write input.tf file for the variables, how to write output.tf file for receiving the output that you require. All of those things you can learn from day 2. So the one that we are doing today is just kind of an introduction, beginner level Terraform. If you want to learn advanced, just go to this playlist and you can perform the tasks. Most of the things will work as is. Let's say you want to integrate the secrets manager with Azure. That is a HashiCorp vault. Steps will remain exactly same because AWS or Azure Terraform integration with the vault will not change. Okay, let's go back. It said 5 resources are created. Let's go to the Azure platform and verify the create. So, okay, I haven't logged into the Azure portal. Let me quickly do it. Sign in, and if I go to the resource groups, I should see this resource group called example resources 1. And within this, I have network interface, I have the virtual network, and I have the virtual machine. And this virtual machine is as per our configuration. It's a Ubuntu virtual machine, right? And if you see here, there is a private IP address, which we have asked for. We have requested for a private IP address in a dynamic nature. So it has generated the private IP address and there is no public IP address, right? Now the step is we create the public IP address. I wanted to show you this one because if there is something missing in your Terraform file, how do you update that configuration? And then how do you implement the missing configuration? That's why I just missed this intentionally. Otherwise, it will take the SSH key value pair from your local. Achha, one more thing is if you don't have the key value pair in your local machine, you can simply go to your Visual Studio Code terminal and run this command called SSH key gen. It will create a key value pair. Before you execute this Terraform script, if you don't have the key value pair in your machine, just run SSH-keygen. Great. Now I need a public IP because I cannot connect from here using the private IP address. And let's say I don't know the code of how do I write the public IP. 2 things. One is you can simply come here. Public IP has to be attached to the network interface configuration, where here you can just say public IP address. So you don't have to remember the syntax. If you have this Visual Studio Code extension, just type public and you will get it. For now, I'll keep it as blank. And what I will do is I will create a public IP through the Terraform itself. For that, just say resource, just type for public and you will get this particular block, public IP address underscore ID. Give a random name. Let me call it as example itself. Okay. Now, okay, Abhishek, you got this. So you understood that you want to create a resource called public IP address ID example. Now what should go inside this block? How do I know that? Just copy this one and search this one in the documentation. Just search for public IP and you will get this Azure RM public IP, right? All that you need to do is just copy this code. This information we already have. I don't need the tags for now. So just copy this. right? So you can just copy paste this one. Now let's run Terraform plan. And I don't want the existing virtual machine to be deleted, as I've explained. Only the public IP should be added. So let's see if we are able to update the configuration using Terraform or not. So Terraform plan, it is now trying to perform the dry run. How does this get all that information from? Because it has something called as state file, right? State file records everything, whatever you have created on the Azure, it will get that information and it will store in this particular file called state file. And when you add or remove something, it can understand from the state file what are the changes that it is going to affect. So it's at 1, and if you look at here, so it is trying to add the public IP address. Let's try with the Terraform apply. Because plan clearly said us that it will apply it will add a new public IP address. So I'm very confident that it should work and I will be able to SSH into my virtual machine. Make sure you have the public key in your local, because I'm using the public key of my machine. Otherwise, you also have to create a public key. You can also create a public key using the Terraform itself. If you don't want to use your local public key, that is also fine. But you have to again go to your Terraform and search for, I don't remember if it is key pair or key value pair. Let me just search for key. Yeah, Azure RM SSH public key. Like, you can also create it from here, but in our video, we are just using it from our machine. So what we will do is, see, everything is getting recorded in this particular folder. Here, there is something called state file, right? But I don't want to keep the state file on my machine. There are multiple reasons. One is the state file might have some sensitive information. Of course, public key is not that sensitive, but let's say the state file has information of the IP address of your machine, and it has some sensitive information like the password or something, or the API tokens. I don't want to keep it on my machine. I want to store it in a centralized location. Or when you are even working in a team, you cannot have the state file on your machine. You need to store it in a centralized location, right? I have explained that thing in the state file management. Why I'm explaining or why I'm referencing you to these videos? Because if you look at the state file, I took 50 minutes to explain the state file. Now, if I explain that one more time, it will be just duplicate effort, because everything, whether it is AWS or Azure, everything will be the same. Okay, let's go back and let's refresh. Okay, so it got reflected. It took some time, but yeah, now we have the public IP address here. I'll just copy it, go to my Visual Studio Code, just run the command SSH -I dollar dot, not dollar, sorry, dot SSH ID RSA, right? So I have my private key here. What is the username? Username we passed as admin user, I believe. Let's see it here. Admin user. So @ public IP. Just grant the access, yes. And if you get permission error, you just need to run this command chmod 600, and on the file where you are getting the permission error. So you need to grant the 600. So now I have logged into the virtual machine. So I created the virtual machine, virtual network, all the required configurations such as network interface, subnet, and I got the virtual machine created through the Terraform. Now let's perform the second step that I've explained, where, okay, Abhishek, you logged into the virtual machine. I have this entire thing, but I don't want the state file here because I'm working in a team and this state file should not be in my machine. because sometimes this scripts that I'm using, if I push it to the Git repository, my friends or my colleagues might use it. So we require a centralized state file. And if they run the Terraform, their changes should be updated to the state. If I run the Terraform, my changes to be updated to the state. Okay, there is no problem. What we can do for that is create one more file inside the dummy folder called as backend.tf. And within this backend.tf, just write Terraform backend. What is your backend? Your backend is Azure RM. And here you need to write your backend configuration. What is the Azure backend configuration? That is, in Azure, for storing the Terraform state file, we will be using Azure Blob. In AWS, just like how we use S3 bucket, in Azure, we will be using the Azure Blob. And the configuration for Azure Blob is pretty straightforward. You just need these 4 fields. You can get them from the documentation as well, right? So you just need these 4 things. One is, what is your storage account name? What is your Azure Blob name? What is the file name that you want to migrate? I want to migrate this one, terraform.tf state. So that will be my key. Finally, what is the access key for your Terraform backend? That is like, what is the password or what is the API token for me to access the backend file? Sorry, for me to access the Azure Blob, right? So now what I'm going to do, this key, access key will also indicate how Terraform can connect to that particular blob storage and push the Terraform state file. So first, I will create a storage account. And I will create a blob where we can store these files. You can also create this through Terraform, but this is like one-time configuration where you can use this particular blob for all of your Terraform scripts across your organization. So whether or not, it's up to you, because this is just a one-time thing. Storage account name. Let me provide the same thing here. If it is taken, I will change it. But yeah, this is here. East US, click on the advanced. I don't want to change anything else, right? I'll just click on the create button. So review. And if the review is successful, running final validation, perfect. Click on the create. So now I will also have the storage account. Within the storage account, I will create the blob with name backend. That is a container with the name backend. If you change any of these things, please also change it in the file. Otherwise, you will run into configuration errors. Perfect. Deployment is in progress. Shouldn't take much time. It will hardly take a couple of minutes for the blob to be created, storage account to be created. Now go to the resource, click on containers, create a container, which is blob. Now I've created a blob storage with name backend. And within this backend container, there is nothing, right? Now, if I just run Terraform init, initializing the backend, I'm running Terraform init one more time because I want the backend configuration to be taken. And it clearly mentioned that I need access key. So where will I get the access key? Just if you go back, okay, go to the storage account, go to this particular thing. And if you just search for access keys within your storage account, you will find this key. Just click on the show button and copy it, right? So I just went to the storage account, Azure backend storage Abhi, which I used, and I just went to the access keys, copy it, paste it here, Don't worry, I'll also tell you how to secure it. Then run the Terraform in it. So the best way to secure this access key is you can also use it from environment variables, but the best way that you can do it is integrate this either with your Azure Vault or the HashiCorp Vault. So the HashiCorp Vault is pretty straightforward because I have the steps here that is available with documentation and video. So I have explained how to connect Terraform with Vault. Again, this is irrespective of AWS or Azure. So you can connect Terraform with Vault and just use the same thing. Let me go to my Visual Studio Code. Perfect. It said Terraform has successfully initialized. Now, if you run Terraform plan, it should not show for any changes because the backend configuration that we have updated is only for storing the state file. Okay, Terraform plan is getting executed, acquiring state lock. It shouldn't show any changes, and it should show that your Terraform configuration is latest. Yes, no changes. Perfect, we are good. If we go to the blob, containers, backend, we should see the Terraform file here. Now this will be your state file. You can simply come here, remove the Terraform state file. You can also remove the backup because you can configure good backups in the Azure blob itself. And there is no state file here, but if I still do Terraform plan, right? I'm doing Terraform plan. It will read the state file from the Azure backend. Now it will not read that thing, the state file or any information from your machine. You have deleted everything. So this is how you can perform the state file migration. And whenever you are making any new changes, I'll just show you in a second. No changes. And if I just add anything new, let's say here in the main.tf, let's say we add one more property for virtual machine itself. Let's say I want to add the tags, right? Let's say add a very simple key value pair where I'll just say foo is equals to bar. And now if you run Terraform plan, see it can read the information from your state file, not here, but from the backend, and it will tell you that, okay, I will be adding the tags. And with this, we can confirm the state file migration is complete and we are all set to use Terraform using the remote backend. Any additional configuration, you can variabilize this particular Terraform files. You can add workspaces to it. You can add providers, multi-providers to it, everything by following this particular playlist. Whatever you want to improvise, you can improvise. But I just want to help you understand that if you learn Terraform, it is very simple. Whether you want to create resources on AWS or Azure, all the concepts will remain the same. Only the provider configuration and the resources configuration will change, right? So that's it. It said one thing to change, that is the tag. Thank you so much for watching today's video. I hope you really enjoyed it. See you all in the next one. Take care. Bye-bye.